of you. Today we are going to do permutations and combinations, and in this session we'll be discussing the formulas and some important types of sums. That's what we'll be doing. Okay, now the basic premise of Combination chapter is the addition and multiplication rule. So suppose if there is a bag, it has got 5 red, 5 white and 5 black balls. Let's say there is a bag and it has 5 red, 5 white and 5 black balls. So, and the question is that in how many ways can you take out 2 balls of the same color? Suppose there is a question that there is a bag, it has 5 red, 5 white and 5 black balls, and the question is that in how many ways can you take out 2 balls which are of the same color? Suppose there is a question like that. So and 5 red are all identical, 5 white are identical and 5 black are identical. Like these 5 red, they are all identical. So the 5 red balls are all identical, 5 white balls are identical, 5 black balls are identical. The question is that in how many ways you can take out 2 balls which are of the same color. So the answer is 3 ways. The answer is 3 ways, because you can either take out 2 red balls, or you can take out 2 white balls, or you can take out 2 black balls. So there are 3 ways. So either 2 red or 2 white or 2 black. So total there are 3 ways in which you can take out 2 balls which are of the same color. So this is called the addition rule. So what is addition rule? Addition rule means that if the event can happen in either this way or this way or this way, then the total number of ways will be this plus this plus this, that is equal to 3 ways. So this is called addition rule. Okay, now suppose if I say that there is another bag. Okay, now suppose if I say there is another bag, it contains 5 red, 5 white and 5 black balls, and I have to pick up one of each color from this bag also. Like from this bag I will pick out one of each color, and then later on I will pick out one of each color from this bag also. So for this also it will be three ways. So you can pick out one of each color from this bag in three ways and one of each color from this bag in three ways. So the total number of ways So the thing is that the multiplication rule happens when one event follows the other, then you do multiplication rule. But when it is either this or this or this, then you do addition. So remember like this, addition rule means when it is either this or this or this, then you have to do addition rule. And when it is this followed by this, like both will happen, then you have to do multiplication rule. So addition rule and multiplication rule, these are the two basic rules of permutation and combination. Like the whole chapter is actually based on these two rules. Okay. Okay, now let us look at a question which will give us an illustration of both multiplication rule and addition rule. Okay, so let us look at one such question. So there is a question that there is a code. Okay, there is a code. It consists of 1 to 6 alphanumeric characters. So there is a code, some type of code, and it has between 1 to 6 alphanumeric characters, and you have to choose them from A to Z and 0 to 9, like A, B, C, D up to Z and 0, 1, 2, 3 up to 9. So the question is that in how many ways can you do it? Okay, so there is a code, and from A to Z, 0 to 9, you have to choose between 1 to 6 alphanumeric characters. The question is that in how many ways can you do it? That is the question. Okay, another thing is that you have to find the number of ways beginning with a letter, right? You have to find the number of ways beginning with a letter. So you know that from A to Z there are 26 letters, right? So it has to begin with a letter. So from A to Z there are 26 letters. And so suppose there is only one character and it is written that it has to begin with a letter. So suppose there is only one character, so 26 ways. Secondly, suppose suppose there are two characters. So the first one has to be a letter, so 26. Now the second one can be either a letter or a numeral. So that means 26 plus 10, 36 ways. So 26 into 36. The third one, if there are three characters, the third one again can be either a letter or a number. So 26 into 36 squared. And then 26 into 36 cube. And like that, if there are 6 characters, then 26 into 36 to the power 5. So 26 plus 26 into 36 plus 26 into 36 square plus 26 into 36 cube plus 26 into 36 to the power 4, and last is 26 into 36 to the power 5. So this is what I was telling all of you. This is a sum where the multiplication rule and addition rule both are being used. Because see, I am doing plus, 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 plus. Why? Because in the question it is written that the code must have 1 to 6 alphanumeric characters. So I am doing plus because if it is one character, or if it is two characters, or if it is 3, or if it is 4, or if it is 5, or if it is 6. So that is why I am doing plus, right? So I am doing plus because of that. And why am I doing multiplication? Because if I want two characters, so first will be a letter, the second will be a number. If I want three characters, letter, and then either letter or number or letter or number. So each of these individual cases is multiplication rule, like one character, two character, three character, and plus, 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 because it can be any one of these 6 cases. So this is a very good example of both addition rule and multiplication rule. So what you have to remember is that addition rule and multiplication rule is the backbone of this chapter. All the formulas of this chapter are derived from addition rule and multiplication rule. Okay, so basically the final answer is a very big answer, so I'm just leaving it like that. So 26 common, and then it's a GP of common ratio 36. So 26 into 36 to the power 6 minus 1 by 36 minus 1. Since there is a GP of common ratio 36, so this will be the answer, right? Okay, next we come to the three main concepts in this chapter, like okay, so I was telling all of you that basically the three main concepts in this chapter, they are factorial, NPR and NCR. So factorial factorial is of course a factorial of any natural number is that you write successive natural numbers up to 1, like multiply down up to 1. NPR is n factorial by n minus r factorial, and NCR is n factorial by r factorial into n minus r factorial. So these are the three main formulas of this chapter. Okay. Okay, now regarding this NCR, it has got two main formulas for NCR. One is that NCR is equal to NC n minus r, that is number one. The other is that NCR minus 1 plus NCR is equal to n plus 1 CR. So these are the two main formulas. One is NCR equal to NC n minus r, the other is NCR minus 1 plus NCR is n plus 1 CR. So these are the two main formulas of combination. Okay. Okay, so there is a very important rule related to factorial, that if you multiply r consecutive natural numbers, like if you multiply n plus 1 into n plus 2 dot 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 up to n plus r divided by r factorial, right? So okay, just 1 minute on this. Okay, so I was telling you that in factorial there is a very important rule that if you multiply successive r natural numbers, like if you multiply n plus 1 into n plus 2 into n plus 3 up to n plus r, that means if you multiply successive r natural numbers, the product will be divisible by r factorial. So this is a rule. The product of successive r natural numbers will be divisible by r factorial. Now, what is the reason behind this rule? Like this rule, what is the reason behind it? So the reason is that if you multiply above and below with n factorial, so this will become n plus r factorial by r factorial into n factorial, and that is n plus r cn. So if you multiply successive r natural numbers, the product will be divisible by r factorial. So the proof is that you multiply them by r factorial and above and below put n factorial. So n plus r factorial by r factorial into n factorial. So this n plus 1, n plus 2 up to n plus r by n factorial into n factorial is there here. So this entire numerator is n plus r factorial and denominator is r factorial into n factorial. So the whole thing is n plus r cn, and any permutation or combination is always an integer answer. So n plus r cn is an integer answer. That means it has been confirmed. So remember, this is a rule. The product of successive r natural numbers is always divisible by r factorial. It's a rule. Okay, another very important question which has come in some competitive exams is that if you add 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial, if you add this series, you will never get a perfect square. You have to prove it. Like you keep on adding as many factorials as you want in succession, you will never get a perfect square. Okay, this is a rule. Now, what is the reason? So actually 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, this is 120, this is 720. Now the thing is that 1 plus 2 plus 3 plus 6 is coming to 33. Like 1, 2, 6, 24, if you add them, you will get 33. And then you have several numbers ending with 0. So if you add 1, 2, 6 and 24 and then many numbers ending with 0, then the answer will end with 3. It will definitely end with 3. Now any perfect square will have to end with either 0 or 1 or 4 or 5 or 6 or 9. Right? Any perfect square will have to end with either 0 or 1 or 4 or 5 or 6 or 9. A perfect square cannot end with 3. So this is also one question. I'm just telling you, I'm saying it to you like a theory, but this is a very popular question, that if you add successive factorials, the answer cannot be a perfect square, and this is the reason behind it. So um, these are the main theories and the formulas related to factorial, NPR and NCR. And related to NPR, there is a very famous sum which has come in different exams. That is so 1 into 1p1 is basically 1 into 1 factorial, 2 into 2p2 is 2 into 2 factorial, 3 into 3p3 is 3 into 3 factorial, and n into npn is n into n factorial, right? So this is a very common sum which has come in the exams, and the answer is that you have to prove that it is n plus 1 factorial minus 1. You have to prove that this whole thing is n plus 1 factorial minus 1. Okay, now what you do is that 1 you write it as 2 minus 1, 2 you write it as 3 minus 1, 3 you write it as 4 minus 1, and n you write it as n plus 1 minus 1. So this will become 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial, and this last one is n plus 1 factorial minus n factorial. So 2 factorial minus 1 factorial plus 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial, and last one is n plus 1 factorial minus n factorial. So this is n plus 1 factorial minus 1, that is the answer. So it is coming to n plus 1 factorial minus 1. So these are the various theories and concepts related to factorial, NPR and NCR. Okay, now let's have a look at one question based on NPR. So the question is that there are 10 guests, okay, there are 10 guests out of which 3 are ladies. Okay, there are 10 guests out of which 3 are ladies. The ladies insist on sitting together and 2 of the gentlemen refuse to take consecutive seats. So in how many ways they can be seated? So there are 10 guests out of which 3 are ladies. The ladies insist on sitting together and 2 of the gentlemen refuse to take consecutive seats. So in how many ways they can sit? That is a question. So in this question what we do is, this type of question is very important. In this type of question what we do is that we consider the human beings together equal to one human being, just for the sake of solving the problem. So like for example here what you do is you consider the 3 ladies as one person. So if the 3 ladies is one person, then there are total 8 persons. So the answer will be 8 factorial into 3 factorial. Now suppose you take the 3 ladies as one person and the 2 men as one person. So in that case hello? Okay, actually that will not be very helpful because the numbering is haywire. What you do is, I will give you an easy option. You just ask any person who looks like a local person, where is Mohinder apartment? Mohinder, M-O-H-I-N-D-E-R, Mohinder. So Mohinder, no, Mohinder তুমি মহিন্দারে এসে আবার আমাকে কল করো, I will wave my hand. I am opposite to Mohinder. Hello? Yeah. So basically there is a live stream happen. You sit in the second.
So do I take off?
Yeah. Okay, so considering the 3 ladies as one person and 2 men as one person, so then what happens? The number of waves is 7 factorial into 3 factorial into 2 factorial. I will be doing these live streams. Can you say what can you please start for? I will catch up. I'll catch up. So basically if you consider the 3 ladies as one person and 2 men as one person, then what will happen? The number of people will be 7, because you have taken 3 and 2 out of 10, and then you have taken them as 2 people. So 7 factorial into 3 factorial into 2 factorial. So the number of ways in which the ladies are together is this, and the number of ways in which the ladies are together and the men are together is this. So we don't want the men to be together. So the final answer will be this minus this. So the final answer will be 8 factorial into 3 factorial minus 7 factorial into 3 factorial into 2 factorial. So the number of ways in which you have 3 ladies together is this, and the number of ways in which 3 ladies are together and 2 men are together is this. But we don't want the 2 men to be together, so the answer will be this minus this. So this is the way to do this type of question. Okay, then we come to the next formula, that is in permutation. If you have P alike of one kind, Q alike of second kind, R alike of third kind, then the number of permutations is n factorial by P factorial into Q factorial into R factorial. So this happens when P are alike of one kind, Q are alike of second kind, and R are alike of third kind. That is the time you have to use this formula. So okay, so okay, so suppose let us say there is a question that there is a bag having there are 5 identical black balls, 7 identical red balls and 6 identical green balls, and the question is that in how many ways you can arrange them so that at least one ball is separated from balls of the same color. Suppose that is a question. So there are 5 identical black, 7 identical red, 6 identical green. So total 18. Now if you don't have any particular restriction, then it will be 18 factorial by 5 factorial into 7 factorial into 6 factorial. Now suppose if you say that all the blacks are together, all the reds are together, all the greens are together, so then it will be minus 3 factorial. So 18 factorial by 5 factorial, 7 factorial, 6 factorial is the number of ways, and then 3 factorial will be if you say that all the blacks are together, all the reds are together, all the greens are together. So if you subtract these two, then this will be the answer, that at least one ball is separated from balls of the same color. So this will be the answer using this formula. Okay, next let's discuss dictionary problem. The next is dictionary problem. You see, dictionary problem is there in almost every school book. If you have a doubt, you prompt me, huh? Sure. Even if I am teaching. Okay, so dictionary problem is actually very common in virtually every school book. You will get this question. So what is the dictionary problem? So in this actually what will happen is that let's take a typical question. Suppose there is a word like cinema. Suppose there is a word like cinema. So I want to arrange the alphabets of the word cinema according to the dictionary, and I may get some meaningless words, means grammatically words which doesn't make any grammatical sense. So I want to know that if I arrange the alphabets of cinema according to the dictionary, then what will be the rank of cinema? This is very common question in virtually every school book, you will get it. So CINEMA. So we will say like this, that alphabetically speaking, ACEIMN, these are the 6 alphabets. ACEIMN, these are the 6 alphabets. So if I start with A, then I have another 5, so 5 factorial. If I start with C, then after C next I can put A. Then I can put E. So if I put CI, then I can put A again. Then CI, then I can put E over here, then CIM, then CINA, and finally cinema is the word. So if it starts with A, there are 5 factorial ways. If it is CA, then 4 factorial ways. CE, 4 factorial ways. Then CIA, 3 factorial. Then CIE, 3 factorial. CIM, 3 factorial. CINA, 2 factorial. Then this is 1, this is 1. So if it starts with A, 5 factorial, then CA 4 factorial, CE 4 factorial, CIE 3 factorial, CIE3 factorial, CIN3 factorial, CINA2 factorial, and CINEAM1 and CINENA1. So now let's add it. So 120 plus 24 plus 24 plus 6 plus 6 plus 6 plus 2 plus 1 plus 1. So let's add the whole thing. So this is 120 plus 24 plus 24 plus 6 plus 6. So if I add everything, what am I going to get? 120 plus 24 is 144. 144 plus 24 is 168 plus 6 is 174. Then 180, 186, 188, 189, 190. So the rank of cinema will be 190, right? So this is a very, very common question, dictionary problem. So the formula is I am used to it. And I hope it helps. So the next formula is in permutation, if repetitions are allowed, then instead of NPR, the formula is n to the power r. So this is if repetitions are allowed. So let's have a look at one question related to this. So have a look at this question. How many numbers of 5 digits can be made with at least one repeated digit? That is the question. So how to do this question? In this question you have to say that first let's consider repetitions allowed, all the possible answers. So repetitions allowed. So it will be 9 into 10 into 10 into 10 into 10. Okay, because you are allowing repetitions. So 9 into 10 into 10 into 10 into 10. So that is coming to 90,000. And this is 99876. That is 27216. What is the logic behind 99876? That means that there won't be any repetition at all. So 9 into 9 into 8 into 7 into 6. So if you subtract these two, then the answer will come 62784. So the question was how many numbers of 5 digits can be made with at least one repeated digit. So 9 into 10 into 10 into 10 into 10 is 90,000 and 99876 is 2726. So if you subtract these two, the answer is 62784. Okay, next let's have a look at the geometry problems using NCR. So you all know that NCR is number of combination or number of selections of n things are at a time. Now you have some geometry problems based on NCR. So let's just have a look at those. So there are n coplanar straight lines. So no two are parallel and no three are concurrent. Okay, so have a look at this question. N coplanar straight lines are there. Okay, there are n coplanar straight lines. In the same plane there are n straight lines. No two are parallel and no three are concurrent. So the question is how many new lines can be formed by their intersection. So there are n coplanar straight lines, out of which no two are parallel and no three are concurrent. So how many new lines can be formed by their intersection? That is the question. So this type of geometry based question is very common in NCR. So the first thing you have to understand is to get a point you have to take two lines. So there are n lines. To get an intersection point you have to take two lines. So if you do NC2, then you will get an intersection point. And then if you take any two intersection points, you will get a line out of that. So NC2, C2 will be the answer. So that means n into n minus 1 by 2 into n into n minus 1 by 2 minus 1 by 2. Now the problem is that when you consider one line, suppose you consider one line, so it will intersect every one of the other n minus 1 lines, right? And there are n lines. So every line will meet other lines at n minus 1 points, and out of those n minus 1 points you should not take 2 points, right? Because then you will get the same line. So from this you have to subtract n into n minus 1 C2. So I'll just repeat this again. You have n coplanar lines, so intersection point will be NC2. Now out of NC2 you have to take 2 at a time, so NC2 C2. So NC2 C2 will be this calculation, and then you have to subtract this number. What is this number? That every line will meet all other lines at n minus 1 points. So out of n minus 1 if you take any 2, so that's n minus 1 C2, and those two you should not take. because they'll give the same line. And since there are n lines, so you have to subtract n into n minus 1 C2. So ultimately the calculation will be like this. So n into n minus 1 into n square minus n minus 2 by 8 minus n into n minus 1 into n minus 2 by 2. So after you subtract them, so you take n into n minus 1 by 2, 8 common, into n square minus n minus 2 minus 4 into n minus 2. So it will be n into n minus 1 by 8 into n square minus 5n plus 6. So ultimately the answer is n into n minus 1 into n minus 2 into n minus 3 by 8. So this is the way to apply geometry in the formulas of NCR, right? So this is one example of that. There can be a lot of other types of sums, but this is a good example for the kind of sum you can expect in the competitive exam. Okay, then another kind of sum is suppose A is a set with n elements. So application in set theory. Suppose A is a set with n elements. A subset P of A is chosen and A is reconstructed by replacing the elements of P. Then a subset Q of A is chosen. Find the number of ways of selecting P and Q so that they are non-intersecting. So first one set was given A. So from that you choose a subset P. Then you replace all the elements of P and reconstruct A. Then you choose a subset Q. And how many ways can you select P and Q? So that they are non-intersecting. That means they don't have any elements in common. Okay, so how to do this sum? Here you have to do like this. For every element, there are three possibilities. It belongs to P, does not belong to Q, does not belong to P, belongs to Q, does not belong to P, does not belong to Q. So if that is the case, then for each element there are three ways, but there are n elements. So answer will be 3 to the power n. And you have to exclude the case when P and Q are null. So from 3 to the power n you have to subtract 1. So the answer of this question will be 3 to the power n minus 1. Yeah, but are you doing the MCQs or everything?
Starting off with exercise 2.
So exercise is towards the beginning of the book or
the beginning.
End like here say about that?
And then that is chapter block. This is mostly theory. Some are good from the exercise theory, and over here, this part is totally subjective, but I solved from permutation combination because it had good sums. This one I don't really know. But after from this is basically all MCQs and maths stuff. Starting since I've just started, I'm doing the easy ones in the beginning.
Carry on. Okay, now let's consider one type of question, different type of selections. So different type of selection means that we are not very sure how many we are going to select at a time. We may select one at a time, two at a time. It's not very clear. Okay, it is written that there are 5 mangoes and 4 apples. In how many different ways can selection of fruits be made if number 1 fruits of the same kind are different and number 2 fruits of the same kind are identical? Okay, and it's written how many different ways, so we are not sure how many are going to be selected. So how to do this type of sum? So the first part, if the fruits are different, then you will have to say that for mangoes it will be 2 to the power 5 because each mango you can either select it or reject it. So 2 into 2 into 2, 5 times, so 2 to the power 5. And for apples it will be 2 to the power 4 because each apple you can either select it or reject it. So 2 into 2 into 2 into 2, so 2 to the power 4. So the number of ways will be 2 to the power 5 into 2 to the power 4 minus 1. So that will be 2 to the power 9 minus 1. So this will be the answer of the first part. The second part, it is written that fruits are identical. So for mangoes, it will be 5 plus 1 because you can take either 1 mango or 2 mango or 3 or 4 or 5, or you can take none. So 5 plus 1, and apples 4 plus 1, and then minus 1 because it shouldn't be that you didn't take any fruit at all. So 5 plus 1 into 4 plus 1 minus 1, so the answer is 29. So this is one type of sum, that is, so what are the formulas? Like if everything is different, then the formula will be 2 to the power n minus 1 like we did over here. And if things are identical, then the formula will be p plus 1 into q plus 1 into r plus 1 minus 1, like that. So once again, if things are all different, then 2 to the power n minus 1 will be the formula. And if the things are identical, then p plus 1 into q plus 1 into r plus 1 minus 1 will be the formula.
So I think your son called me. I gave a missed call before when I reached us. I think your son called back. He has some calls. It's the same number for some reason.
Oh.
Yeah, something like that.
1 second.
Wait, so no. No. So I don't know, it was someone who sounded like your son. I don't know. Around some weird number.
That's it. Okay, so circular permutation of this is for human beings. Okay, for human beings, circular permutation is n minus 1 factorial. And for inanimate objects, it is half into n, and if it is inanimate objects, it is half of n minus 1 factorial. So there's this question, in how many ways 10 men can sit around a table so that in no two arrangements they are the same neighbors. Now remember one thing, all of you, that why is there a separate formula for human beings and inanimate objects? Because in human beings, circular, clockwise and anti-clockwise are considered different, but in inanimate objects, clockwise and anti-clockwise are considered the same. So it's written 10 men sit around a table so that in no two arrangements they have the same neighbor. So if no two arrangements they have the same neighbor, that means we'll have to consider it as clockwise, anti-clockwise both are clockwise and anti-clockwise both are the same. So then this formula will be used. In no two arrangements they have the same number, that means clockwise and anti-clockwise will have to be considered the same. So then this will be the formula, right? So the answer of this question will be half of 10 minus 1 factorial, because clockwise and anti-clockwise will be the same. So this will be the answer. Okay, actually there are two very important topics in competitive. One is called the grid problem and the other is called the derangement problem. I'll just discuss those two. Now there is a slightly complex topic called the multinomial theorem. That I think we will have to do it in the next session, because I don't think it will be possible to fit that into this session. It's a little complicated. So what I'll do is that in the conclusion of today's meeting, I'll just tell you two topics. One is the grid problem and the other is the derangement problem. So what exactly is the grid problem? So there is a 4x4 grid and you have to start your journey from X and end at Y. So there is a 4x4 grid. Now the question is that in how many ways can you start from X and reach Y? The condition is that at a time you can either move one step horizontally or one step vertically, and you have to start from X and reach Y. Okay, that is the question. So in this there are 4 horizontal steps and 4 vertical steps. So if you call the horizontal steps as H1, H2, H3, H4, and if you call the vertical steps as V1, V2, V3, V4. So what you have to do is you have to take 4 horizontal steps and 4 vertical steps. But remember that unless you do H1, you cannot do H2. Unless you do H2, you cannot do H3. Unless you do H3, you cannot do H4. Unless you do V1, you cannot do V2. Unless you do V2, you cannot do V3. Unless you do V3, you cannot do V4. So total you have to take 8 steps, and there are 4 like this and 4 like this. So the calculation will be 8 factorial by 4 factorial into 4 factorial, which is 70. So total there are 8, out of which 4 are horizontal and 4 are vertical. So 8 factorial by 4 factorial into 4 factorial, this is 70. So this is called the grid problem, right? The second one is derangement. Now derangement means that derangement means that there are 4 envelopes, suppose E1, E2, E3, E4, and there are 4 letters. L1, L2, L3, L4. So you have to post these 4 letters in these 4 envelopes. But the condition is that it has to be completely deranged. That means that the opposite of arranged. There should not be any arrangement. So if you put L2 here, L3 here, so this will be L4, L1. Then L2 over here, L4, L1, L3, L2, L1, L4, L3. So these are 3 derangements in which L2 goes in E1. Similarly, you can have L3, L1, L4, L2. You can have L3, L4, L1, L2, and L3, L4, L2, L1. And similarly, you can have L4, L3, L1, L2. You can have L4, L3, L2, L1. You can have L4, L1, L2, L3. So there are 9 derangements. There are 9 derangements of these 4 letters in the 4 envelopes. Now, what you can do is that you can do this sum in another way also. You just write one series like this. There are 4 letters and 4 envelopes, so 4 factorial, and then you begin a series 1 by 2 factorial minus 1 by 3 factorial, and it should end with 1 by 4 factorial, because that is the number of letters and envelopes. So that is coming to 4 factorial. So ultimately the answer is coming the same 9. So L1, L2, L3, L4, 4 factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. And after calculation the answer is coming to 9. So the same answer is coming, but obviously this is a very lengthy method. You have to actually write down all the cases, and this is a direct method where you just have to fit the formula. So the only topic left in this chapter is multinomial theorem. I think it will be better if we catch up with that in the next session, because I don't think that it will be a good idea to fit that into this session. It is a very it's a slightly different topic from the rest of the chapter. So except multinomial theorem, we have completed the chapter. So on that note, I'll wind up this session and we'll continue the next day with multinomial theorem.